in order to help us see what's going on here, I've actually pulled in a picture of a graph from the Desmos online graphing calculator. This red curve is the graph of the function f of x equals x minus the cosine of pi x. And we're supposed to estimate the area under that curve between the x-axis from 1 to 5. So that's this pair of points here. Here's 1 and here's 5. And we're supposed to use two rectangles. What does that mean? Well, the length of that interval from 1 to 5 is 4. So we could say the width of each subinterval is 5 minus 1, which gives us the distance between 5 and 1, divided by 2, since we want two rectangles. So that tells us that the width of each rectangle will be 2. And that's what I've kind of depicted here. There's one of the rectangles, and I'll raise this just a little bit higher so you can see the difference. And then we're supposed to use the midpoint of each of those rectangle bases to help us calculate the height of the rectangle. What that means is we need to determine the midpoints of the interval from 1 to 3, which is 2. And then if we evaluate f of 2, we get this distance right here. That will help us create our first rectangle, which will look like this. And similarly, the second rectangle has a midpoint of 4, so this is the midpoint, or this is the f of 4. And since that's the height of the second rectangle, there's the second rectangle. So if we could calculate the areas of these two rectangles and add them together, we would be estimating the area under the curve. Now, as you can see, for two rectangles, it's not going to be very accurate because of all the missing space that's not covered. But how do we do that? So rectangle 1, what is its area? Well, the length of the rectangle is 2 in each case, and its height is f of 2. So we need to actually figure out what f of 2 is. Well, f of 2, I'll come over here. What's f of 2? We have to put 2 into the function definition. So it's 2 minus the cosine of 2 pi. But the cosine of 2 pi is 1. So the height of this rectangle is 1, which that kind of looks like what we got there. So the area of that first rectangle is just 2. And in a similar fashion, f of 4 will be 4 minus the cosine of 4 pi. But the cosine of 4 pi is also 1. Or 3. So the area of rectangle 2 is 2 times 3, or 6. And if we add the areas of those two rectangles together, we get 8. So that's basically how you do it. Now I'm going to share my screen and go to Desmos and show you that there's a Desmos graph where you can actually do this and change the number of rectangles and the endpoints if you want. You can see I've defined the function here as x minus the cosine of pi x. And I said the left endpoint is 1. The right endpoint is 5. The number of subintervals is 2. And I'm using 0.5 to say that we're going to use the midpoint of each rectangle to calculate the height. And we can see that this is a formula for actually the sum of the areas of those rectangles, where f of s sub I is actually the height of each rectangle, and w is the width, which we've already seen is 2, and there's the answer of 8. I think, no, they didn't actually calculate the exact area. But if I increase the number of rectangles, you can see that as the number of rectangles gets bigger and bigger, we're getting closer and closer to the area under the curve. And so it looks like 12 might be what the real answer is. If you haven't already, someday you'll learn how to calculate the exact area under this curve as the definite integral from 1 to 5 of x minus the cosine of pi x dx. And you could type that into your calculator. If you have a calculator that does definite integrals. But I'm going to stop recording and